Let's get started by defining some terms we'll use today. First is Layer 2 address, which is also called a physical address, a MAC address, or an Ethernet address. All these names refer to the same kind of address. The most correct term would be Layer 2 address, although it's probably the least used, with Ethernet address being the most common. During this course, we'll commonly call it either a Layer 2 or a MAC address. Layer 2 is the physical layer of the OSI model and deals with the physical method of sending data over cables. When a network device is manufactured, it's assigned a Layer 2 address. This address is burned in as the device is made and remains with it its entire life, which is why we call it a physical address. It's almost impossible to change the Layer 2 address of a device. Bridges use this address when forwarding traffic. Think of the Layer 2 address as the computer equivalent of its Social Security number. You have it for life. Our next term is a Layer 3 address, which is also called an IP address, a network address, or a logical address. Once again, all these names really refer to the same type of address. Layer 3 is the network layer of the OSI model. It determines how data is transferred between computers. The Layer 3 address is a logical address assigned by a network manager. This address can change many times depending on the use of the computer, and it's also dependent on the software loaded on the computer. If IP communication is used, then it's an IP address. If Novell software is used, it may be an IPX address. And if AppleTalk software is used, it's an AppleTalk address. Most people use IP today, so it's commonly called an IP address. The Layer 3 address is like your phone number. Many things can cause it to change throughout your life. Our last term is hexadecimal format. This is the common way Layer 2 MAC addresses are written. Hexadecimal uses a format of 16 characters rather than the typical 10 used for decimal numbering. Hexadecimal uses numbers 0 through 9 and letters A through F. For example, to denote the number 12 in decimal format, 2 digits are used, a 1 and a 2. However, in hexadecimal format, 12 is represented by the letter C, only 1 digit. This allows us to define 16 values with 1 digit instead of just 10. Hexadecimals allow higher numbers to be stored in less space.